Okay, so it says notes 4.1, graph proportional relationships. So the first thing, yours is going to look a little different than mine. It changes the fonts when I pull it up in Google Drive and it doesn't allow those fonts. That didn't work. So a way to determine whether two quantities are proportional is to graph them on a coordinate plane. If the graph is a straight line through the origin, then the two quantities are proportional, okay? So if it's a straight line through the origin. So let's look at our first example. A racquetball player burns 7 calories a minute. Determine whether the number of calories burned is proportional to the number of minutes played by graphing on the coordinate plane. Okay, so looking at that table, make a table to find the number of calories burned for 0, 1, 2, 3, and 4 minutes of playing racquetball. So right here, they show you, okay, there it is, sorry. They show you right here. So they say at 0 minutes, okay, you have 0 calories burned. So after your first minute, okay, of playing racquetball, you burned 7 calories. After 2 minutes, 14 calories. After 3, 21. So it's going up at the same rate. Are you with me there? Okay, by 7, yeah. Okay, so that means it's proportional, right? We kind of talked about that before, yes? Okay, so it's going up proportionally by 7 every time. It started at 0, 0. Okay, so what was our characteristics? If you go scroll back up a little bit and say, look at that top. A way to determine whether two quantities are proportional is to graph them on a coordinate plane. If the graph is a straight line through the origin, then the two quantities are proportional. What is the origin, people? 0, 0. So if our chart tells us that it's going to start at 0, 0, is that going to be proportional? It doesn't even have to start there as long as it goes through that point. Are you with me? Okay. So, graph the ordered pairs on the coordinate plane, then connect the ordered pairs. So they have graphed it on this coordinate plane. They said at 0 seconds, okay, at 0 seconds it's 0 calories. At 1 second it's 7 calories. 1 minute, sorry. Is it minutes? Sorry. At 2, at 14, I wish I'd do it. Okay, at 2 minutes, it's 14 calories. At 3 minutes, 21, 4, and so on. Do you see how that pattern is happening? So it's plotting the chart that's above that table and putting it on a graph. Are you with me there? Okay, so write down past that. Okay, it says the line passes through the origin and is a straight line. So the number of calories burned is proportional to the what? To the number of minutes of racquetball played. Okay, so it's because it's going up proportionally. So I want you to look at example 1. Sorry. They show you, I don't know how it clicked back over there. Okay, Coach Elkins spends $7 a month plus 10 cents per minute. Determine whether the cost per month is proportional to the number of minutes. Okay, by graphing on the coordinate plane. So, no, it should be that first one, I think. So, Coach Elkins spends $7 a month plus 10 cents a minute. So think about that wording. What's that wording saying?
I wish I could spend 10%.
Okay, that would be cool. But what's the base price? So where are we starting at 0 minutes? How much has she spent?
$0.
Not quite.
0.10 cents. No, you have to do 10 times $600.
Hold on. At 0 minutes, how much has she spent?
$7.
Why?
Because she gets.
That's her monthly plan. That's like a monthly plan, right? Okay?
Not 0 months.
Huh?
Right, but if you have this plan and you're paying $7 a month for it, even if you never use it, you're still paying that $7 a month.
Okay. If you have a cell phone, you're paying monthly whether you use it or not. If you're on a contract.
Oh.
You understand that? So you got to pay that no matter what. So at 0, she's starting at 7, right? So right here, Okay, that's not quite on the line, sorry. Okay, and then 10 cents a minute after that. So at 10 minutes, how much would she have spent for 10 cents a minute? She would spend another $1, right? So at 10 minutes, it would have cost her $8. Right here. $8. Okay? At 20 minutes, it would have cost her another $1 because there's another 10 cents, 10 times 10. So it would have cost her another $1, okay? So she would have been at $9. Man, I'm having a hard time today. Okay, so she would have been at $9.
Wait, but why would she be at $9 if she paid $7 a month?
Because she's paid $7 a month and she's talked for 20 minutes. So 20 minutes times 10 cents a minute is $2, right? And $7 a month plus her $2. Okay, so let's keep going. Are you with me? Okay, so at 30 minutes, how much would her time be?
At 30 minutes.
Her time would be $10, right?
Yeah.
Okay, and then it's going to go up $1 for every 10 minutes after that.
$10.
Okay, so it's going up in a straight line if we connected them all, right? Now, is this what we talked about proportional? Yes or no? What do you think?
No.
Okay, what did you say? Repeat it.
I said no because it doesn't start at the origin.
Perfect. No, because it does not start at the origin. So we're going to say, is this proportional? No, because it does not start at 0, 0. It starts at 0.7 because it's at $7 per month. Are y'all good with that? Okay. So flip over and look at number 2. Number 2 says a person can burn 8 calories per minute of running, whether the number of calories is proportional. Determine whether the number of calories is proportional to the number of minutes. Okay, does it say anything about anything else other than 8 calories per minute? No. So where are we going to start at 0, 0 if we were to graph those lines?
Be 1 and 8, right?
Well, let's start with 0, 0 first, okay? Oh, man.
Because if you haven't started working out, you haven't burned it, right?
Okay, so we're going to start.
If you haven't done any work yet, you burn 0 calories.
You understand that? So at 0, 0. So at 1 minute, how many calories have we burned? 8. Okay, so at 1 minute we burned 8 calories. At 2 minutes, how many calories have we burned? 16. Oh man, I didn't put that in the right spot. I can't see that side graph on here for some reason. I'm so sorry. Okay, at 3 minutes, how many calories have we burned? 24. At 4 minutes, 32 calories. Okay, and so it's going up. Is this graph proportional?
Yes.
And it goes up in a straight line, if you could draw a straight line, and I can't, even with this fancy pencil.
Wait, we have to graph 5 too.
The writing's still considerably better.
Oh yeah. Yes, it's proportional. Yeah, you need to draw your line showing that's going up. It's linear. Linear means it's going in a line. Okay, right? Line, linear, and then proportional means it's going up. It's going through 0, 0 and going up in a straight line. Okay. Number 3, if Stephanie sells 3 necklaces, she earns a $5 profit. If she outsells 4 necklaces, her profit is $10. 5 necklaces, her profit is $15, and 6 necklaces sold gives her a profit of $20. Determine whether the amount of profit is proportional. I'm going to draw a table on this one first, just so we can put those points there. Are y'all good with that? Yeah. Okay, so let's draw a table. So what our X is going to be our necklaces. You good with that? Necklaces. Man, I am not for neat today. Maybe I need to sit down and write on this. Okay. So let me start again. Okay, so here we are, and then this is going to be necklaces. Right here is going to be cost. So let's be cost. Well, cost is going to be your Y, right?
Yeah, in the chart, Y goes
So,
on the bottom.
so on the chart, Y goes on the bottom.
When you set up your fraction, you do cost over whatever.
Okay, so I'm going to explain that to you. Okay, so remember how we talked about that? This is going to be your X, and this is going to be your Y. How would we write that proportionally? K equals what? Y over X. So what's our Y? Our cost. And that's how we talked about writing cost over numbers, right? When we talked about proportions. Okay, so that's going to break it down that way. Okay, so let's fill in the rest of our, so at 3 necklaces, the cost is, she profits 5. At 4 necklaces, she profits 10. At 5 necklaces, she profits 15. At 6 necklaces, she profits 20. Now, so it looks like if you do the change that this is proportional, right? But here's the thing. Right here, this is 5 and this is 1. This is 1 and 5. Remember how we did that, right? Okay. So, here's the deal. If I went back to 2 necklaces, it would be, I would make 0 money. So what does that essentially say?
It's
Not proportional, okay? Because it does not go through 0, 0. So if I said revert back, 2, I would be 0, and that would give us that change that we were having here, okay?
Why did the other one start at 0, 0 and this one doesn't?
Okay, it's just the way the wording's set up. It's not proportional. Yeah. So I'm going to say not proportional over the top of that. And I could have graphed it and gone a straight line, okay? So it's still linear. It's still going up at a straight, she's going to continue that. But maybe she had to pay for her supplies with the first 2 necklaces she made. And then, so we're going to say it's not